Hi everyone, we'll solve the fourth worksheet. So we start with the third question. Here we have a poker deck, okay, and we'll select 5 of them. We want at least one of them to be ace, okay. Now in a deck we have 52 cards, and as we want to select 5 of them, we have this combination. Now we want at least one of them is ace. To find that, we will subtract this part, this probability, which is the hands, it contains the hands with no ace, okay? Because at the end, we will find the probability of this. So what's this? What's this probability? So how do we compute that? We have 52 cards. And in a deck, we have 4 aces. So we subtract them. We have 48 cards in a deck now without aces. So we select 5 of them as by computing this combination. So we have this. This is the probability where the hands does not contain any ace. Okay. So finally, we can subtract this from 1 to get the desired probability. Here we have, these are the operations, you don't have to compute all of them. So this is the probability of the hands with at least one ace. Now we have a dice, we roll it, okay, and we want that a die never comes up an even number, okay? And we roll it 6 times. So what do we do? Remember, for a die we have 6 outcomes, okay? We have 6 many outcomes from 1 to 6. And we roll 6 times that dice. So we have 6 to the 6 outcomes, okay, in total. And what do we want? We want that a die never comes up an even number. So we have 3 odd outcomes, right, for each roll, because either 1 will come, or 3, or 5, okay? So we have 3 odd outcomes for each one, and we roll it 6 times, so we have 3 to the 6. So what's the possibility? What's the probability? Here we write the desired outcomes, which is 3 to the 6th. And here we write the total, which is 6 to the 6th. So we have this probability. So here for this question, we have a roulette and a wheel with 38 numbers is spun, okay? There are 18 red numbers and 18 black numbers. And we have these two outcomes too, 0 and 0, 0, okay? So we know that the probability when we spun this wheel, it lands on any particular number is 1/38. So each one has the same probability, okay? Each outcome has the same probability. So first, we want to compute this probability that for the red numbers, okay? So as I said before, for this question, so here we write the favorable, the desirable outcomes. As we want red numbers and we have 18 many of them, we write 18 here, and total is 38. So we have this probability for red numbers. Here we want black number, but now we spun it twice, okay? So we want black and then again black. So remember we have 18 black numbers on the wheel. So we have 18 times 18 over 38 times 38, Okay. For this, we want either 0 or this 0, 0. Okay. So we separate it by or here. Okay. We have two possible, so we have two outcomes. Okay. Either we want it, actually we have one outcome, but we're okay with these two. So we can see them as separate events. Okay. So we have only 1 0 on the wheel, so 1/38 we have, plus again we have only 1 0 0, so we have 1/38 again. Thus we add them and we have this probability. Now we want that when we spin the wheel, we want that we never 0 nor 0 0 comes. Okay, so we have in total 38 many outcomes, and we have these two, okay, that we don't want to see on the wheel. So we have 36 outcomes now in total. Okay, so for each spin we have 36 outcomes. Now, but remember we spun it 5 times, okay? So we have 36 to the 5 outcomes that we want, that we desire. And in total, 38 to the 5 outcomes. So we have this number. Now we have a pair of dice, okay? We roll them again. So we know that the probability that a 4 appears on the first die, okay, remember that, on the first die is 2/7, and for 3 on the second die is the same, 2/7, and other comes to appear with the probability 1/7, okay? We want to load these two dices, okay? And we want the sum to be 7, okay? So we need to have either 1 6 or 6 1 or 2 5 or 5 2 or 4 3 or 3 4. So we need to compute each one's possibility, okay? Then we will add them. So what's the probability of this pair? So each outcome besides these two ones, the probability is 1/7. So we write for 1, 1/7, and for 6, 1/7 again. So we have this probability. And these ones' probabilities is the same with this one, right? Because each one has 1/7, has the probability 1/7. So we have the same for each one, same probability. What about this? So remember, 4 appears on the first die with this probability. So we write 2/7. And for 3 on the second die, it's the same, okay, with 4. So we have this probability for that. And these have the same probability with these ones, because here we have 3 on the first die, right? So if it was second die, then we would write 2/7, but it's on the first die, so don't make the same mistake with me. Okay, so it's 1/7, and for the second die we have 4, it's again 1/7, because when 4 appears on the first die we have this probability. Okay, so we have 1/49. Thus the probability of this sum to be 7 is the sum of these probabilities. So here we have 9/49. Now we want to compute the conditional probability, okay? We randomly generate bit string, okay? and its length needs to be 4, okay, and it needs to contain at least 2 consecutive zeros. And here we have the condition with the given with the first digit 1, okay. So here we denote this event to generate the bit string has 1 in the first digit by A, and we denote this event, okay, which has 2 consecutive zeros by B. So we compute this. As we want to compute this conditional probability, we need to compute this. So this P of A is here 2 to the 3 over 2 to the 4. Why? Here we have all outcomes, right? We have 4 digits, right? Let me write it. We have 4 digits. Each one has 2 outcomes, right? So in total, we have 2 to the 4. And why we write here 2 to the 3? We know that the first digit is 1, so we have this, okay? Now we don't have any outcomes for that, but for them. So we have 2 to the 3. What about this? So now for this, we know A, we want both A and B, right? So we want the first digit to be 1, okay? And for these ones, we want at least 2 consecutive zeros, okay? So what are they? What are the possibilities? What are the outcomes with this condition? One of them is this, right? Here we have 2 consecutive zeros and first digit is 1. Here, first digit again is 1, and for that it's the same. And here we have we set at least 2 consecutive zeros, and here we have 3 on, and here we have 2 consecutive zeros. So we have many possibilities for that, many outcomes. So we have 3 over 2 to the 4, right? Again, the total number of the total number of bit strings of length 4. So we have this number as the probability that we desired. Now we will find the probability for this situation. So we have a family, okay? They have 5 children and no boy, okay? So for the first part, we know that a boy and a girl has the same probability, okay? Having a boy or having a girl has the same probability. So what's that? What's the probability of having a boy or a girl? So we have either boy or a girl, so the total number is 2. And if it's a boy, we have this probability 1 over 2. And again, if it's a girl, again we have 1 over 2 the probability as the probability. So, but they have 5 children, right? So for each one, we have this probability 1 over 2. Thus, we have this probability 1 over 32. Because we have 5 children, that's why we write 1 over 2 to the 5. And if the probability of having a boy is this probability, okay, if it's this, the total number, it's we need to subtract this one from 1 to find this probability having a girl, okay? So it's this. This is the probability of having a girl. Again, they have 5 children, so we need to compute like this, okay? So we have 0.49 to the 5 probability. This is the probability of having 5 girls with this probability with for each of them. Now here we have a set S. It contains numbers from 1 to 99, okay? And we choose subsets of it, okay? We want to find the probability that the subsets or the selection of subsets with an even number of elements, okay? So what's the total number? By total, I mean the number of the subsets of S. Okay, it is 2 to the 99. If the number of a set is, if the number of the elements of a set is n, then the number of its element, number of the subsets of this set is 2 to the n. Okay, so it has 99 many elements. So this is the number of subsets of S. Okay, it is exactly the same with writing this one. Okay, this is the number of the subsets of S with 0 elements. This is with 1 element, this is with 2 elements, until 99 elements, okay? Now, what's the number of subsets consisting of an even number of elements? It is, so as we say even number, it should be containing either 0 elements or 2 elements or 4 or 6 till 98, okay? So we need to compute these ones, the number of these subsets. So for 0, we have this. For the subsets with 2 elements, we have this number. And finally, we have this number. So this is equal to what? Remember, we have this equality. 99 choose n is equal to this. 99 choose 99 minus n. Okay, we have this equality. So from that, you can see that this is equal to that. Okay, and this is equal to this. This is equal to this. Okay, we have half of them gives the number of the subsets containing an even number. So this sum is equal to this. 2 to the, remember the total number is this, 2 to the 99 over 2. Okay, half of them is the number of subsets consisting of an even number of elements. Okay, so we have this. Now this is the desirable situation, okay, events. And this is the total number, so we have 1 over 2, okay? But if you know this already, okay? If you know half of the subsets of S has even number of elements and half of them is odd number, then already you know the probability is 1 over 2, okay? So that was the last question that I chose from the worksheet. If you have any problem, you can send me email, or also you can attend the office hours, which is on Fridays between 5 p.m. and 7 p.m. So see you next week.